Hi, and welcome to Software Design and Development, Option 2, Lesson 2, Binary and Decimal Conversions. Here are the dot points, pause if you'd like to read them. So, in decimal versus binary, we represent quantities using the decimal or base 10 number system. And it's called this as it has 10 digits, and there they are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. However, we also can represent this using the base 10 number system. So we have a subscript there, and we can use 25 little 10 to represent that that's a base 10 number. Okay. Computers use the binary or base 2 number system, and it's called this as it has two digits, 0 and 1, and base 2 numbers are represented with a 2 in subscript. So here's an example of a base 2 number, and we have the little 2 there. Okay. We have an infinite number of bases. If you can think of any number, you can have a base of that number, and you can just represent a number with that little base there. All right. So often it is useful to be able to convert between decimal and binary so that we can see what the computer sees. So the important notes you need to know about converting between binary and decimal. Okay. The way you work with these numbers is exactly the same. There is no difference between binary and decimal apart from the numbers that you use. Alright. We won't show you any new techniques that you haven't learned in your maths classes. However, it might have been some time since you did it, so you might have forgotten them, or you might not have used them in the way before. Okay. You need to understand this because once you do, the conversion process is so much easier. Okay. Do not use a calculator to complete the conversions. Really important you don't use a calculator. Okay. In exams, you won't have one for a start, and most students will struggle with calculations by hand as they become used to calculators. You need the practice. Also, you need to show all your working. Okay. If you skip your steps, you open yourselves to a heap of mistakes. This is particularly important for you people who think you're awesome at maths. Okay. You might skip working all the time and you get away with it in maths class and it's fine. However, you need to show working for this because it's something you don't often do. Alright, no one ever converts to binary and vice versa back. So because you need to know how to do it, you need to do it by hand. Really important. Okay, so first thing we have is this place value. Alright, we have the place value table for decimal numbers over here, which you should have seen before, and we have the one for binary numbers over here. You can see that then they're made from the powers of the base. So here we have base 10 numbers, 10 to the power 3, 10 to the power 2, 10 to the power 1, 10 to the power 0. Over here, it's binary, it's base 2, 2 to the power of 7, 2 to the power of 6, 2 to the power of 5, 2 to the power of 4, 2 to the 3, 2 to the 2, 2 to the 1, and 2 to the 0. Okay, and underneath we have the decimal representations of each of these. So 10 to the 3 is 1000, for instance, 2 to the power of 7 is 128. Okay, we can obviously expand or contract these as necessary. Okay, I can go 10 to the power of 4, 10,000, and go 10 to the power of 5, 100,000, etc. Similarly, I can go over here, go 2 to the power of 8, which is 256. Okay, so how do we do this? All right. In a place value table, each number in the table is multiplied by the value of the place, then added to get the total. So both of these are 179. Okay, this is 179 in base 10, and this is 179 converted to base 2. Alright, so to get the number, we go 1 times 10 squared, so 1 times 10 squared, plus 7 times 10 to the power of 1, 7 times 10 to the power of 1, plus 9 times 10 to the power of 0, 9 times 10 to the power of 0. We can expand the powers out, and we get 1 times 100, 7 times 10, 9 times 1. And then we do the maths, 100 times 100, 1 times 100 is 100, 7 times 10 is 70, 9 times 1 is 9, to get 179. Similarly over here, 1 times 2 to the power of 7, 1 times 2 to the power of 7, 0 times 2 to the power of 6, 1 times 2 to the power of 5, 1 times 2 to the power of 4, 0 times 2 to the power of 3, 0 times 2 to the power of 2, 1 times 2 to the 1, 1 times 2 to the 0. 1 times 128, 2 to the power of 6 becomes 64, so 0 times 64. 2 to the power of 5 becomes 32, and we do the maths. 128 plus 0 plus 32 plus 16 plus 0 plus 0 plus 1 plus 1. Add that up, you get 179. Okay, so if we have a decimal number and we want to convert to binary, it's really simple steps, but it's a long process. Okay, first thing you need to do is draw up your table. Here's my table here, and you get the decimal number you want to convert. and you put it away from your table on another part of the page. And you've got to make sure there's enough room for calculations. In this case, we'll convert 205 to binary. Okay. Obviously, I'm not doing this by hand, so it's a bit difficult to show you the working. You'll be doing this by hand, so working's a lot easier to do by hand. Okay. Just make sure to make the change. So you divide your number by the biggest number you can in the table while still ensuring the answer is greater or equal to 1. You may need to increase your table to do this. In our case, we've increased the table to the next power of 2, which is 256. Okay, so 205 divided by 256 equals 0.8 something. It's not greater than 1. So then we'll use 128. Okay, so 205 divided by 128 is 1 point something. Okay, it's greater than 1, so we'll use that. And so then we do our division. The answer is 1 with some remainder. Write your answer in the place value table. Okay, then minus 128 from 205, calculate the remainder. So 205 divided by 128 is 1 something. Okay, and then we use minus to work out the remainder. So 205 minus 128 equals 77. And that's the number we're going to work with in the next step. So now we divide our answer by 77. Okay, we divide our answer, which was 77, by the next number in the table, which is 64. It's greater than or equal to 1, so write 1 in the table. So we've got 77, we divided that by 64. 77 minus 64 equals 13. Okay, so notice I'm leaving the working here that you can see before. Okay, and any working from the previous step is written in grey. Okay, so really, really easy. We take 77, we divide by 64, we realise it's more than 1, we put 1 there, work out what the remainder is by minusing, we have our answer that we use the next step of 13. So now we divide our answer by the next number on the table. So 13 divided by 32, it doesn't go. Alright, so it'll be 0 point something. Alright, so in this case, we're going to write a 0 and move on to the next step. The next step is dividing 13 by the next number in the table, which is 16. 13 divided by 16 also doesn't go, so we write a 0 and move on. 13 divided by 8 does work, so we write a 1. 13 divided by 8, we minus 8 from 13, we get 5 as our remainder, and we'll use that. The next step, 5 divided by 4, work goes, so we put a 1 there. 5 divided by 4, we have 5 minus 4, we get 1. Okay, 1 divided by 2 doesn't go, so we put a 0 here, okay, which you'll see there. Alright, and then we put a 1 there. And now 1 divided by 1, that always works. We put 1 there, we minus it to make sure we have no remainder. Alright, so now we have a binary number and we want to convert it to decimal. How do we do that? First step, draw up your table, okay, and make it as big or as small as you need. And you get the binary number you want to convert and place it into the table. Really, really important here, you write the digits, the rightmost digit goes in the rightmost slot. Don't start from the left, because if you run out of digits, everything will be in the wrong place. So you always start from the right. So I've got 10011. Okay, that's the 1011. We don't have tens obviously since it's not decimal. Okay, so 1011, and I always write it this way. I write the 1, then the 1, then the 0, then the 1. I don't just write it this way. Okay, because it's very easy to make a mistake. Put something here, and then everything's shifted over a lot of numbers. Okay, so 1, 1, 0, 1. And all we do is our maths. Okay, so 1 times 2 to the 3, 0 times 2 to the 2, 1 times 2 to the 1, 1 times 2 to the 0. Add that up, and you get 8 plus 0 plus 2 plus 1, which equals 11. Very simple.